Welcome to a new test and teardown video. This time it's a Philips PM5168 function generator. But this one is quite special. Probably see the frequency range. Maybe I should go a little bit closer to the frequency range here. This is 5 millihertz to 5 kilohertz. So it's a really low frequency range for this particular model here. Also, I believe it's used for, mainly it was designed for pen plotters or sweep of some experiments like that. In the good old 60s. I mean, this is all we used, right? XY plotters. And because we didn't have storage oscilloscopes, at least most people would not have money to buy stuff like that. And yeah, I think this model is from 1968, according to Radio Museum. I also got another one. I got the 5162. So it looks from a distance more or less like this one, but it is 0.1 hertz to 100 kilohertz, a more normal signal generator range, but it's a sweep generator. I will put the link to my other unit in the description so you can enjoy that one as well. But this one is a, it's of course called a function generator because it can do sine wave, triangle, and square wave. And you probably also see this knob right there. You have a variable sawtooth. See, I think this is a 1-to-1 and 10-to-1, so we can change the shape of this curve. And this is of course very useful when you're performing sweeps for pen plotters. You want to do something like that, right? But if you're performing a sweep on an analog oscilloscope, you probably want to go right here because you go backwards and forward. We got a few cool features. We got the hold, continuous, and single shot. And again, super useful for pen plotters. And look at that. We got a little lamp. And I think this lamp has something to do with single shot or continuous mode. Funny enough, they saved the on bulb. So this is a mechanical. Look, this is some fluorescent paint. It looks like there's light, but no, this is just fluorescent paint. It's really bright and shiny. Probably not shown that well on the video. And we got, yeah, those three outputs here. I think this will be with a fixed amplitude. And then the output from one of these, then you select which one you want down here. And then down here is the output amplifier. And then you can, of course, control DC level and amplitude for the selected waveform. And I hope this is not affecting any of the other waveform outputs. We have a trigger input, and I think this is for starting the single shots mode. Here at the rear, we can see the model. Here is the 5168, but it is the -4 version. And it's got a quite low serial number, only 709. It uses 15 watts, so that is a very useful information. I also like the more modern voltage range, 230, so this is super good. And there's a little lock here, so you can't really move that switch. And there is a difference between the earlier models. You see the two transistors here Others, they only got one of them, so that is also a thing to mention. The power in and power out, that was for their instrument line here. All those instrument lines got exactly this input and output, and you can imagine you just bridge one instrument to the next, to the next, to the next, and this way you have a nice clean table without all those power cables floating around. So that is a little bit nice. We better open and inspect and look for leaked capacitors or anything burned. I also started to clean it a little bit. You can probably see what is going on here. Depending on how much I clean it, I go through different layers. So first there's this smoker layer. And there's actually in 2 different layers. See, there's another one down there, and then there is this layer here on the front, looking like that, and then I cleaned it up nicely and fine down here. Let's get a little bit of light. So I think it can get nice and beautiful. It is, of course, so beautiful. The design inside, they've been thinking about everything. I made one funny mistake about this lamp here at the front. I thought that was related to the trigger and single shot, but look at that. The wires goes to the mains transformer, and there's a resistor like that. I don't know if this is original, but this is for dimming of this bulb. So that is a power on indicator. But why are we having this fancy mechanical indicator here? I don't understand that. Maybe it's an old design as well. Well, the power supply here at the back is made for service. All you have to do is unscrew 2 screws right here, and then you can pull this out of a socket. And I believe this power supply is just 2 identical power supplies, and then they're connected in series for plus minus voltage. It has been serviced a little bit. I see some resistors changed, rectifier bridge changed. See, they're not the same. And I should probably pull out this power supply so we can have a little look and probably better inspect everything. That will be all the different resistors for all the different frequency ranges. We got a lot of potentiometers down here. They're made for easy access to all the calibrations. High precision resistor for frequency adjustment. And look at that. The capacitors here. The capacitors, we got 2 of them. 10 microfarad plus minus 0.5%. And there you have it. 1.1 and 0.01 microfarad. So that will be the time setting capacitors. I can't really read the precision on that one. And see the glass here, that reveals super low leakage. But there is one little thing. Look at the little solder blobs. Here and here and here. I mean, we don't want stuff like that to fall into circuit boards, but luckily there are no circuit boards at the bottom if they fall down. But anyway, here is a little temperature shield. So there's something going on in there that's important. All the timing or the oscillator functions and such is of course done in only using transistors, and I don't know if you can see the black transistors up there. The good old germanium diodes and multiplexing, selecting. Again, all the really old transistors. Absolutely beautiful. The two power transistors here to the left, that's most likely output drive. But I don't find any burned components or any leaked capacitors or anything like that. So is this one loose? No, there's nothing keeping me from powering this up. Maybe we should also enjoy the bottom view. How many potentiometers? I mean, look at all the adjustments. Circuit boards look like you can unclick them and then easily flip them a little bit. You need to loosen the screws here, then you can bend this, and then you can flip the boards, I guess. That should be possible. Look at the trimmers on the power supply. Oh, it's definitely something. Okay, they're low value. Yeah, I want to pull out the power supply and have a little look. So here's the power supply. There are so many clever things we can learn from the good old times when people took the time to design things the correct way. Look how nice and symmetric this is. I should probably show the back, but there are a few little details here. See those little metal parts here? They go through the board and then they fold and lock. So that means when you put the capacitor through this and solder here, now you have a much better and more mechanical stable solution for that solder joint, because it's a big heavy capacitor. So after many years of vibration and so on, the normal fault that we see is that cracked solder joints, but that is of course not the case here. Other things we can see, those two tracks at each side, that's of course the AC input, and there you have a bridge rectifier, and then you go to the first capacitor, then you go to the next capacitor, and then from this capacitor is where you take your power and continue to the rest of your circuit. You don't take this point or that point to that one, but it could have been done that way wrong if you just have a layouter that got no knowledge and no skills, that just follow the schematic or what is the most easy thing to do when he's doing, the layout of this. But of course he's doing the right thing and routing from the correct component. Something like that I really love. And you see there's absolutely no connections between the two halves. The two halves there are connected together at the user side. And that is also a perfect way to do that. The circuit here is just some Zener diodes and some feedback. Maybe we should have a little look what is inside here. This is a little thermal shield, I would expect. And of course, that was a good guess. If you look at those two transistors, you probably note this little mark here. That will be the emitter. Let's see, this goes to the connector side. So we go this way. If you look again, the emitter here and the emitter here, they are connected together. So we got a little differential coupling with two transistors connected together like that. And this is, of course, how they compare the output voltage with the reference voltage, so to speak. Today you would use an op-amp, but in the good old days we used differential coupled transistors. And they need to have the same temperature. Whatever temperature it is not super important, but they want to be the same. Normally you'd put them much closer and just glue them a little bit together. But here they had the idea you put a little shield around them. Either way, I think this is a little bit too much to do out of it, really, but it would have been easier just to glue them more. I mean, mounting two screws, having this one manufactured, I don't know. What do you think is easier? I'm not all done complaining about this power supply here. So I added a little bit of information here about the connector. So I'm of course going to go and measure all these voltages in a second. The AC input and AC input, all those wires here, they're just tied up together, as you can see here. So there's a really good coupling with everything AC and everything DC in all possible ways. I mean, mains input goes directly, I mean, that will be the output transistor, and there's another one down here, and you see these wires, they also go into the circuit board here, and we got the other transistor right there. So what they should have done is they should have taken those AC inputs and those AC inputs, and they should have twisted them and tied them up together with all the other AC lines. I could accept that. And then all the DC stuff and DC output, I mean, tie these up together at least, and then just leave them a few millimeters apart, these two piles of cables. Then it would have looked, you know, pretty intelligent. But this we have here is really bad. There is also another fun thing about this transformer. I don't know if this is easy to see from this angle. I could probably lift it up a little bit more. Yes, that would be better. So if we look at the wires, let's see if we can get the darn thing to focus here. So this wire is the shield, ground, protective ground, and all that kind of stuff. But there's another shield winding in this transformer, and that is the black wire. And black wire goes to the center point, the ground of everything as well. So that means they do not like hum. They really want to have their DC system isolated from mains and from hum. So they did try a lot of stuff. 2 shieldings. Wow, look at that. And then all wires just tied up together. But you know what I'm going to do? I'm going to put in the power supply, measure the performance of the power supply well, in case everything works, right? And then we will see. I can probably cut up everything here and just fix the wires, and then probably, is it possible then to prove it was a good or a bad idea to do this stuff with the wires? Is it on the last 5th decimal, or is it loud and clear? I don't know, but let's try and see. So let's try the first power on and just make sure the voltage is okay. And of course nothing happens here, and there you have it. So it's plus minus 12 volt, and the positive is not super duper accurate. I should probably try and see if I can trim this. So that will be this top trimmer here. And there you have it. Ooh, look at that. Maybe I should just massage the... Because of course this is a very old trimmer. And that was a nice little difference. Lovely. It's using 17 watts, so that is a little bit more than they say. It should only use the 15. Maybe I should warm up my scope and see if it really works. Oh, there's something wrong with the DC level. What the? I did not expect that. Okay, so this is something to do with it. So this should be a sine wave. Holy moly, that is not the case. What do you call that? I don't know. Well, not a sine wave, that is. We got definitely some crossover, but that has something to do with the DC. Okay, so that is in fact working. All right, so, but we got a lot of crossover, so somebody poked around with one of the trimmers that is doing that, I guess. I think it's time to get the manual and see if there's any kind of information about that. Is it also doing this in the other? Yes, it is. And what if I select the... Okay, so it's completely gone in the sawtooth mode. And there you have it, a real nice... Oh, this is curved a little bit. This is not a super straight line. I mean, I can easily see that it is. You can see what I mean. So there's a little... So what else can it do? This hold? And then it goes continuous. What if we go single shot? And then we push the button. Really? I was able to find a manual, and this manual shows exactly how to tune it in and to do to handle all the different adjustments. And of course, this one is very, very complex in the way that it regenerate the sine wave. It renders a sine wave from a triangle, and this is why my sine wave goes really crazy when I adjust the angle of the triangle. So of course there are some rules. I need to move this position here so it's symmetric, and I need to look at the sine wave. Perfectly fine. So in the manual they say, well, they don't reveal the manual version, what kind of version of hardware is the manual for, but they say in the manual, loud and clear, I need to double check and verify that my hardware unit is the correct version. Duh. So that is still a little bit stupid. Also, I can see that my version is the power supply with 2 power transistors, and the manual is the one with 1 power transistor. So I already know there is not a perfect match between my manual and my unit. So let's try and see if we can show both the scope picture and the curves and the trimmers and everything at the same time. So this is a little bit difficult, but hey, let's at least try. So those 2 trimmers here are 30. Look at what happens here. See, this is the top part, and I can move it longer or shorter. So this is where you trim the top sine wave. So I try and see if this is perfectly fine. Then R27, that is the bottom part. See, here it's too wide and too sharp. Oh, the the trimmers really need a little bit of massage. So if this is getting good, maybe here, okay, like that, right? So let's move to the other side, like that, and let's see if we can get a little bit of light in here. And then this is R99. Look at that. So here's the crossover. But now look at what is also happening. So this affects the bottom part. How wide is the bottom part? So now I fix crossover, and now the bottom part is bad. Let me go back and make it beautiful. So there's another one here, R108. This one also fixes crossover, but look at that. Here it's the amplitude, which is not a problem. So this is a better way to do it, right? And then I don't screw up the alignment of the top and the bottom. See here? It's probably even better like that. And there you go. We are back here. And I think this one, what is it? This one is doing, I can't remember. Oh yeah, so this is the DC, which is not super important right now. It was just a curve. So I've of course tried to dial the DC knob in, and then dial this one for 0, so it's not super critical. But that was a little bit about the adjustments. You can of course, I think it's this one that fine-tunes the frequency, so you have a correct frequency. I would prefer, if you see here at the front, the dial here goes from 5 to 50. So I just took 3 because it's a nice round number and it's almost in the middle. If you align everything for 1, so now you should have 1 kilohertz. Now it's 980. But of course, if I dial this potentiometer in, so this is exactly 1K, then it is way off over here. So that's why I was aiming for a perfect hit exactly here, right? And then we can go to 50, it should be 5 kilo, and it's 5.1. So there is some sort of unsymmetric or something like that. Maybe there's a trimmer that handles that. I haven't yet figured that out, but at least I'm quite happy about the curve shape and all that kind of stuff. I went online and found a site that actually sells a unit like this. I think it's called ABEX or something like that. And they also present a picture of the Sinewave output, and they also actually revealed their units also got the same crossover issue. And so at the beginning I was, okay, let's just drop it. It's maybe just the way this generator works. But then I found the manual, and nice curve explains. And of course it can be adjusted to be a really, really good, nice shape. You probably recommend me to go and pick up my GHD meter and put this on the output and then fine tune for a perfect GHD. So I should probably have done that. And that is a very good idea. I think that is all I wanted to show in this video. So thank you very much for watching, and please come again soon. Bye.